Hello everybody, good morning if it's morning, good night if it's night. Actually, most y'all lazy as fuck, so it's probably night. But, anyways, today we're gonna be doing week 4. This is a short lecture. There's not really a lot of information in week 4. It's mostly just mathy things, like nothing too hard. It's mostly things you've done before, just done differently. Okay, so separate the end. So we're doing lower quartile and upper quartile. Basically, what that means is a quarter. Remember, a quarter is just 25%. So at 100% has 2 quarters. It has the 25%, which is from here. Let's imagine this line is 100%, right? This line has 2 quarters. It has this part, which is your 25% mark, and it has this part, which is your 75% mark. Now, you'll be thinking, well, 75% is not a quarter. It's not. But if you think about it, 100 minus 75, this section right here is 25%, which is a quarter. And so, the same thing here, from 0 to 25, like this section here, is 25%. So it's a quarter. Now you could also think, oh, the midpoint, like you could choose a random point, 25%, and that would be a quarter of 100, yes. But when we're talking about lower quartile and upper quartile, we're talking about the bottom 25% and the top 25%, which is between 75 and 100. So separate the n-ordered sample observation into lower half and an upper half. If n is odd, like this is very self-explanatory, but we will do an example with some data right here. So now that you know what a quartile is, a lower and an upper, let's say I give you some data. I'm just gonna choose numbers that are the same, because you know what, why not? Okay, so usually you can't really get your quartiles unless you order your list. So if these numbers were random, you will have to order them. And then once you're done ordering them, your quartile, first you want to choose your half. So we have 1, 2, 3, 4, 5, 6, 7, and then you want to choose the mid of that 7, so your median, which would be this position. Remember, this is odd. We will do an example when it's even. So since this is odd, that means we split it into 2 halves, which is 22, 44, 55, 66. So you see I included it. And then 66 again, 77, 88, and 99. So now that we split it into 2 halves, remember your line is 100%, right? So right now what we just did, we went to the half mark, and now we have 50% by 50% of our data. Right, that's our 2 groups. Then we're gonna split it into half again. So we're gonna take this, split it into half, which is our 25%, and then split this into half, and this is our 25%. So what I want to know now, my 25%, what number does it land on? So if I take this, remember this is my 50%. If I split it in half, it'll give me 25. So if I split it in half right here, this section is 25. And this section is also 25. But which number lands at that exactly 25? Because they're even, you just add them up and divide by 2. So you'll do 44 plus 55 divided by 2. And whatever that number is, that's your lower quartile. And then you'll do the same thing here, is you'll take these 2. So you'll do 77 plus 88 divided by 2. And that will give you the upper, so at whatever the point is at 75. Remember, when I say quartile, is I want the number that lands at these 2 positions, okay? Which is the 25% and the 75%. So that's one way to do it for a odd original list. For a even list, it's easier, because, well, would it be easier? It's really the same. So let's add 100. So you see now we split it in half, which will be right here. But now it splits perfectly. So we'll just have 22, 44, 55, 66, and then 77, 88, 99, and 100. And then we take this, and then we get our median again, which is going to be these two added divided by 2, and same thing here. And that's how you get your lower and upper quartile. Now your IQR is basically just the difference between the two. So in other words, it's the distance between the two numbers. So remember, once we calculate this, here, let me do it real quick. So I have 44 plus 55 divided by 2. This will be 49.5. And this one will be 93.5. So my IQR is basically the distance between these two. Like, how far is it? So 93.5 minus 49.5, which will give me 44. And that is basically the distance from this number to this number. It's the distance between your 25 percentile to your 75 percentile. And that is your IQR. Okay, now what about continuous distributions? So remember, this is for raw data. This is when you have like a bunch of data, raw data, and how you do it. Now we're going to do it for continuous distributions, which is now you have a function. Obviously, you can't just take numbers and split it in half because it's a continuous function, right? That would be too tedious. And so, well, we know we're looking at our point at 25%, and we're looking at our point at 75%, right? And so, when you want to do it, how do we find the upper and lower quartile of a continuous distribution? In much of the same way. So remember before, if we integrated from some number to m of f of x dx, and we make it equal to 0.5, it gave us the midpoint. This is how you find the median of a continuous function. We learned that in the previous lectures, is if I have a continuous function, let's make it exponential, and I want to find the median, I will set it to 50%, and that will give me the midpoint, whatever m is at. So since I want the 25% and the 75%, that means to get them, what I'll have to do is just change this, which is 0.25. So now what I'm doing is I'm doing from 0, which technically this is not going to be 0. Your function doesn't exist in the negative, but in math you always got to cover all cases. So this will be negative infinity to m, and then this will eventually go from negative infinity to 0, which cancels out. Then it will go from 0 to m, and that's what you'll do. So in other words, you'll be doing 0, not negative infinity, because your function doesn't exist past 0. So what we're saying now is I want from 0 all the way to 25%. Okay, and that would be whatever my m value is at. And the other one, to get our 75%, which is somewhere here, right? What we'll do is the integral. So now you have a couple ways of doing this. You can do it, so remember, we're looking for m. We can either do from negative infinity to m of f of x dx, and make this equals to, so hold up, let me erase this so it looks clear to you guys. Let's do this. There's two ways to do both of them. So here, let's get some room. Okay, so imagine this is your function, and let's make it exponential. Actually, let's make it like this. Okay, so we have 2 points. We're trying to get this point right here, and we're trying to get this point right here, which is one covers, let's assume this is your 0, well, 25%, here I'll write it in red. So this is our 25%, and I want this section, which is also 25%, right? I want the quartile, so this is also 25%. Let me make it up over here so you see it better. Right? I want these two 25%. So I want this m, and I want this m. So what are the couple ways? There's 4 ways to do all of them, and 2 ways to do each. So this one, if I were to integrate from my 0 or negative infinity, so we're going to go more negative infinity to my m, that would be 25%, right? So this would be f of x dx equals 0.25. The other way I could do this is, what if I do it instead of that, I'll do it from here all the way to infinity. So I could also integrate this from m. Remember, I'm still talking about this m. I could also do it from this m to infinity of f of x dx. Oops. But now this is no longer 25. This section is 75%. So I could set this to 0.75. And that would still give me the same thing. I'm solving for m. I'm solving for that point at the 25% mark. So this would be the same thing. Just understand your bounds. Your bounds matter and what you equal it to. Whatever your bounds are, they should cover what you're equaling it to. So you see here, from negative infinity to m, which is from 0 to m, that covers 25%. And this one, from m to negative infinity, which is of this m, that one is 75%. Now for this one, it's the other way you can do it. So here, let's make this n instead. So this is going to be n. Now we're going to integrate. If I do from 0 to n, right? If I do from 0, from here to n, that would be 75%. So of my f of x dx equals 0.75, right? That's 75%. This would give you the answer. The other way you could do it is from n to infinity, which is technically to 1, of f of x dx. And this one will equal, well, since this is 75, this has to be 25. So this will be 0.25. And this is how you can get your quartiles in, for continuous functions. You just got to make sure your bounds are right and the area they cover, like in percentile. Okay, so any observation farther than 1.5 IQR from the closest quartile is an outlier. So basically is you want to take your IQR, which is, remember, it's the difference, which we did I write it somewhere? Yeah. So this is the difference between the two. If I take this number and I times it by 1.5, so the distance from my 25% point to my 75% point, that's my IQR. If I take that and I multiply it by 1.5, then whatever after that point, so if I take 44 times 1.5, that'll give me 66. So anything outside 66 is an outlier. And anything outside 3 times the IQR, so remember, 1.5, that's just a mild outlier. And then anything more than 3, so if I do 44 times 3, which is 132, that would be an extreme outlier. Okay, so that's basically what it says, is that it is mild. Otherwise, if it's 3 times extreme, it is 3 times the IQR, it's extreme. That's what your IQR says basically when you look at your data. So given the following, right now we're going to do box plots. Box plots, you use your IQRs, and so that's what we're going to do here. Giving some data, we need to find the upper and lower quartiles, the median, and the IQR. Then we can find the outliers. So, thankfully, Mrs. Paula has put our in lower and upper. But if she doesn't, remember, you have to first take this and organize it, which is already organized, so that's good. Then you want to count how many there are. So 1, 2, 3. Here, let me number them. That's so tedious. 16, 17, 18, 19, 20, 21, 22, 23. Jesus. Okay. So they're 30, which is an even number. So if they're even, you can split them exactly in half. Wait, no, if it's even, then their midpoint is odd. Am I tripping? I might be tripping. So basically, you want to take this and split it into 2 halves. You could see she already did it here. And we'll split at this point right here. Because you have 15 and you have 15 between here and here. So you'll split it. And then, since we spoke about it earlier, how do you find your lower and upper quartiles? Is after you split it, you want to get the mid again. So since we know this is 15 long, our midpoints is going to be 7 and 8. So 1, 2, 3, 4, 5, 6, and then we have here. Let's do, so it's 15. That would be 7. So 7, and then 1, 2, 3, 4, 5, 6, 7, and 8. So our 2 points will be these ones, I believe. Thing is, I don't like how they're overlapped, so it's hard to see the middle, and I'm kind of stupid when it comes to stuff like this. But the point is, take the 2 middle points. If it's odd, choose the one in the middle. If it's even, add the 2 in the middle and divide it by 2. Okay, so here, first let's find the median, which is just the midpoint. And since we don't have a midpoint, then what we'll have to do is just add these 2 up and divide it by 2. So 196 plus 197 divided by 2. That'll give us 1. So here, I'll write it here. 196 plus 197 divided by 2. And this will equal 196.5. So that's your median. And now we're going to do our quartiles, which is we want the mid of the lower and the mid of the upper. So let's do that. You know a smarter way to do it? Watch this. This is not so smart, but I feel like it's smart. So you do 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, and 8. So you see there's our mid. You don't even gotta add nothing up. And so we could do the same thing here. 1, 1, 2, 2, 3, 3, 4, 4, 5. This is my autism kick in. 6, 6, 7, 7. And that's your 8. So that would be your median. So we have here our lower quartile. So lower, or in other words, Q1 equals 191. And then our upper, which is Q3, equals 191. Wait, no, 204. Oops. 204. Now you might think, why is this Q1 and Q3? Let me tell you guys. If you do finance, which I doubt any of you guys do finance, but if you do finance, a year has 4 quarters, and each quarter is 25. Well, no shit. So imagine it's 100%, right? So you'll have the first quarter at 25, and then you'll have the second quarter at 50, and then you'll have the third quarter at 75, and you'll have the fourth quarter at, well, that would be at 100, and that would be your Q4. And so that's why this is Q1 and this is Q3. Okay, so that's really it for quartiles. Is if it's raw data, you just want to split it in half and then split it in half again. If it's continuous, you just want to integrate to that point at 25 and 75. Since our sample size, it says it here, it's even. The first ordered 15 numbers go in the lower, and the first, oh wow, no shit. Okay, now we're going to do bivariate data. So, a couple things with data. Let me show you a couple examples. So far, we've been doing a lot of single variable data. Okay, so you'll have some data, some graph, and the only variable that matters is x. So now we are going to be doing data that matters on 2 variables, y and x. And you're going to be like, well, what does that mean? Like, let's say I have data of height and weight of a person. Okay, so we're doing height, right? A person's height plus a person's weight. Does a person's height affect their weight? And the answer is yes, but there are some other variables, like if they're obese, their diet, blah, blah, blah. But also, if you think about it logically, the taller the person, the bigger their size, therefore the more they weigh. The smaller, the more compact, and so you weigh less. So, let's say I want to do an experiment. I have a bunch of data between people of height and weight, and I want to see if they correlate. And so, for example, let's say this is height, and let's say this is weight. Then, as a person's height increases, their weight also increases, right? So, our data, if I collect a couple people, and it will look something like this, let's say, right? It will just have like a bunch of points, and you see how they go up together positively. Now, with this data, you'll have some outliers that go like this. And this is the fat ass. If you're a fat ass, go to the fucking gym. But this is the fat ass that is short as shit and fat. And you could also have somebody tall as shit and skinny. So these are outliers that you'll have, and that's okay. They will skew your data. There are some mathematical things you'll do to fix that. But we're not paying attention on fat asses today. We are paying attention on statistics. So once you build this data, as you can see, this data goes up and it's very compact. So you could say this is a positive and strongly, or what's the other words? I forgot the other words. Shit. It's positive and direct. So positive, well, not and direct. You could say direct in other words, right? Relationship. That's a relationship between the two variables. So that's one of them. Now you can have a negative relationship, just like your love life. So let's see. Okay, hotness. So how attractive someone is, plus their love, how much they love you. So the more attractive they are, the less they love you, because the better you look, the more you hoe. Anyways, so let's assume the hotter you are, the less you love. And let's say this is love, and this is hotness. So the hotter someone is, the less they love. So if you're up here, your X would be here, right? Because your love is very low and you're very hot. And then as you become less hot, the more you love. And so your data will keep going downwards. The hotter you get, the less you love. And then you'll have, obviously, the odd ones that are hot as shit and they love you the most. But these are usually in your dreams. And you also have the ones that will love you the most, but they're very not hot. And these are usually called homeless people. So that's where you have a negative relationship. Just like your love life, negative relationship. And in other words, it's called an inverse. Okay, and we have one more type, which is nothingness. Let's say the correlation between your major and your IQ. Wait, no, that's bad. Okay, listen, it's just a bunch of data that doesn't just correlate, it's just fucking spread out everywhere, alright? So this is basically just no relationship. There's no relation. Okay, so these are the types of data you have. No relationship or very little. Maybe there is a relationship, but it's very little. Okay, and there's one more, which is technically the same as the one we just did. Let's say your data goes like, instead of a straight line, it actually curves. So this is still a positive relationship, so it's direct with curvature. I can't spell. You get the point, okay? So that's basically what it is. These are the three types. It's not really rocket science. You just read it. If it goes up, it's positive. If it goes down, it's negative. If it's all over the place, it's nothing. And if it's positive, it's just direct with a curve. So now we're going to be doing Pearsons sample correlation. What does that mean exactly? Now I know the math looks fancy, but don't stress it. It's actually very simple. It's a little bit tedious, but it's very simple. So you see how here we looked at the data and we're like, okay, so this one's positive, this one's negative, this is nothing. But what if I want to know exactly how tight or how in numerics, like as a number, like if you were to tell me how strong do they relate, like between height and weight? how relatable are these two things? Is it a very strong relationship? Do they relate but not too much, or do they not relate at all? So if I want to put that in numbers, that's what Pearson's sample correlation R gives me, is that it will basically tell me how strong these two relationships are, or these two variables are. And so what you'll have is you have this big ass sum, which is just SXY, and then you'll have this big ass sum, which we've done in last week, SXX and SYY. So how do you get these? In your calculator, this is for raw data, by the way. This is for raw data. So in your calculator, and I spoke how to do it for a sharp calculator yesterday, or last week's lecture. What you'll do is you'll plug in all your points in your stat mode, and then you'll get this one from your this whole thing. You get it from your calculator, and pay attention to this. You will be getting this one from your calculator. These two are not the same. Okay, please don't make this mistake. These two are not the same. This one is this number, whatever this number gives you the calculator, then you square it. This number, you don't square it. The calculator will give you xi squared, because basically this one is x at I squared plus x at I squared plus x at I squared plus. This one, however, is just x at I plus x at I plus. And then you apply this square to this whole thing. Whatever the whole addition, then you square that. So these are two different things. Okay? So that's what you gotta pay attention to, is that these two parts are different. So once you plug in your data, you'll get these two, and then you'll just plug this one here, minus, plug this one here, square it, and then divide it by your n. So that's how you get your SXY. Your SYY is the exact same thing you do for the XY, except you put your Y points. Also, one more point I would suggest is this correlation does not depend on which one goes in X and which one goes in Y. So if I were to bring this here as my X and I bring this as my Y here, it won't make a difference. Okay? So keep that in mind. So here, like if they give you two types of points, you don't gotta sit there and be like, oh, which one's my X? Which one's my? It doesn't matter. Okay? So that's that. This one, basically, the difference between these two is that this one, you got your X right here, you plug that here, you got your Y right here, you plug that here. This fancy one is, what you'll do is you'll plug into your calculator your X and Y points, and then it will give you the sum of both of them multiplied. So this is basically your X at I times your Y at I plus your X at I times your Y at I plus, well, this is I plus 1, and then xi plus 2 times y I plus 2 plus, and then so on. So that's basically what this one tells you. So then once you get all these, I don't know why I was leading it like that. There you go. Once you get all these, you plug them in, and you'll get your xy. Remember, all here, I'll number them. So this one, this one, this one, this one, these two, and this one. These are all, you get them from your calculator. So the rest of it is just basic math. Once you get all three of these, your SXX, SYY, and SXY, you just plug into this beautiful looking formula. And that's about it. That's how you get your R. And that number will tell you how strong your relationship is between your X and Y. So here it says the value R is always between -1 and 1. A value near the upper limit, +1, tells us there is a positive relationship, whereas an R close to the lower limit suggests that there's a negative relationship. So it's not necessarily like a negative, it has to be close. Here, I'll draw you a little table. So you have some line. Doesn't this sometimes straighten out itself? Well, I guess not this time. -1 and 1. So that's your R. It's between -1 and 1. And then you have your midpoint, which is 0. So if your R is 0, that means there is, well, no relationship almost. Here, let me change the color. We also have our negative 0.5, and we have our positive 0.5. And then we have our 0.8, and we have our negative 0.8. So this is how you read this. So you'll have here is negative and strong. Oops, strong relationship. So if you calculate your R and you get it between these two numbers, it's negative, and this is positive and strong. And what I mean by strong is something like this. Like this. You see how the points are very tight together? That's basically what it tells you, is that they're very strong. Here is mild, I believe. So this is, well, not mild. It would be moderate. So this is going to be moderate. Is that they're not too strong, they're not too weak, but it's still negative. And this is positive, but moderate. Moderate. And then between these two sections is just a weak relationship. So weak positive, and this is weak negative. Remember, just negative basically says it goes downwards. So you see both of these, I would suggest that they are strong because they're very tight together. But if I had like a graph, here, I'll make the graph right here. If I had the graph here and my points were like, so you see, like, they're very spread out. So if you do the line of best fit, it would be here. They're very spread out, and like maybe this is moderate, I guess. You could have something weak, more like this. So you see, it's still going downwards, it's still negative. However, it's more weak, like it's not as tight. That's what she said. But so that's what R says. If you get it as 0, which I've never seen that happens, but if you do, it's basically there's no relationship between the two. So that's that. Now we're gonna do the equation of the least square line L is given by. So this is basically, listen, don't let this bullshit you. This is y equals mx plus b. Okay, this is y equals mx plus b, bro. That is the same shit. They're just trying to confuse you. Don't let them play games on you, bro. But basically, this is just the line of best fit. Okay, so this is the line I've been drawing right here. The way you calculate it is your SXY, which I taught you how to do. It's the sum of your XI and YI minus the sum of your XI times the sum of your YI all over N. So that would be your SXY, and your SXX equals the sum of your XI squared, not squared, this is from your calculator, and then the sum of your XI, then you actually square this one, and then over N. So you take these two, you divide them, that's how you get your B, and your Y. So you see here, I don't know if you rewrote it, but it is what it is. Your Y and your X, these are X bar and Y bar. Do you guys remember what X bar and Y bar is? It is the mean. Okay, if you got it, nice. If you didn't, go study. Well, you're studying, I guess. So your X bar, basically, if you guys remember what it is, it's the sum of your X's divided by N. So if you have your Xi right here, you just divide that by N, and that's your X bar. And same thing for your Y bar. So that would be the sum of your Y's divided by N. So if you didn't plug in the calculator, and let's say you have like 5 points, like 1, 2, 3, 4, and 5, to get your X bar, you do 1 plus 2 plus 3 plus 4 plus 5 divided by 5. So that's how you get your X bar and Y bar. Okay. And that's about it for today's lecture. Actually, I didn't think it was going to be done this fast. But do I not have any more? Oh, that's it. So you see, it's not it's not too bad. We learned a couple things. Quick recap. Your quartiles are your whatever the point at your 25% and your point at 75%. If it's raw data, you first split it in half, which you get. So first you have your sum data, you split it in half, and then that would be your 50%, right? And then you split that again, which is your 25%. And then you split this data again, which is your 75%. And you want whatever point at these two. Okay, so that's your for raw data. For continuous, which is functions, you want to integrate from 0 to m of the function at 0.25, and you want to integrate from m to infinity, which in other words is 1. This is in other words negative infinity of f of x. And you will set this, since it's from m to 1, this is 0.25, which will give you from this point. And this one will give you from here. Okay, so that's really what we learned. We also learned 1.5 times the IQR. So the IQR is the difference between Q3 minus Q1. 1.5 times, here, let me make this, 1.5 times your IQR is mild outlier, and 3 times the IQR is a, what does it say? Extreme. Listen, my English is not the best. Outlier. Okay, so that's your IQRs. That's all we learned for the first part. And then for bivariate, we said that your function can either be positive, negative, no relation, or direct, which is positive, but with curvature. Okay, so that's when it comes to graphing. When it comes to finding how much they relate numerically, we find something called Pearsons sample correlation, R, which is just a variable R. You will have the equation of how to get it. One thing you want to remember about R is that it's between -1 and 1. From 1 to 0.8, positive or negative, you either have a strong positive or a strong negative. From 0.8 to 0.5, positive or negative, it's moderate. From 0 to 0.5, positive or negative, it's weak. And then we also learned how to get the line of best fit, which is, in other words, the least squares line L. B is a given equation, your xy over your xx. If your R is a positive correlation, remember, let me make this point clear. If your R, you calculate your R and it's positive between, from 0 to 1, right? Your B is also going to be positive, because remember, your B is your slope. So if R says it's positive, which means the slope is positive, then B should also be positive. Don't confuse, B does not equal R. They're two different numbers. However, their sign is the same. So if R is negative, B has to be negative. Okay? And that's about it, really. Yeah, this is your function, the same as this function, just rearranged to get your A. Your x bar and y bar is just the sum of your x's divided by n and the sum of your y's divided by n. And that's about it for today's lecture. I hope you guys learned something. Week 4, we only have 2 more weeks, and then which is week 5 and week 6. And then from week 7, we only have 1 lecture. And that's about it. So I'll see you guys on the next one.